Hi, good afternoon, everybody. As introduced, I'm Nick Thorne, and as was mentioned in the opening remarks for the conference, many people here have been coming to this many times, and will probably be instantly aware that I am not Tommy Minyard. That's my boss. He sends his apologies. He had a family-related reason why he couldn't be here today. But I'll be going through the Lustre-specific portions that my group at TACC managers. So they are the support systems for a large number of our clusters, including the two flagship systems. So I'll get to some of the outline of that in a second. I'll go over a quick intro to TACC, and then Frontera and Frontera and Stampede2 are our two flagship systems. And then Stockyard is a particularly interesting example, I think, for a group like this, which is our site-wide file system mounted on all of the clients in our data center. And then our operational challenges that we experience, and finally some of the testing of particularly Flash-based parallel file systems that we're extremely interested in at the moment. So this is a top-down 100-foot glance at TACC, big overview. We have about 185 staff as of 2022, and a fairly substantial data center that's actually split between two physical facilities, both on the J.J. Pickle campus in Austin. And then the main thing being the systems and services. So as you can see, Stampede and Frontera are both listed as our track 1 and flagship systems. So I'll go through that. That's going to be the focus of the talk. And then just a little note about our users. This is kind of a marketing people slide. So 15,000 direct users is kind of all users ever, and the active user count is a little lower than that. But so that's the Texas Advanced Computing Center. So I'll move straight to looking at Frontera. So just a quick note about the structure of the compute before we dive into the storage backend, which is what everybody here is interested in. So we're looking at 8008 dual socket Intel Cascade Lake processors. Our fabric is an HDR 100 InfiniBand network to the compute nodes. So this is obviously a generation of processor that's got PCIe Gen 3. So the best we could do is 100 HDR 100 to each node. And then the HDR network is 200 from the top of rack switches to core. And then the storage subsystem, I got a slightly better diagram for this in a few slides' time, so we can go into a bit more detail, but it's based on the 18K exascalar storage arrays. It's actually the 18K X's, which is the generation where the OSS and MDS servers are hosted as virtual machines on the controllers themselves. So that was new to us and slightly differs from some of the prior systems that we've hosted in the past, but has actually worked out quite well once we kind of got a handle on all of the commands. It hasn't been completely seamless, but pretty good. So in addition to the bulk storage, which is a total of 56 petabytes, and is broken down into 3 separate smaller file systems. Again, more details on that later. There is a 3 petabyte IME system, which is an all-flash file system, and that's also actually slightly broken up these days. So I'll get to those details in a second. And then Frontera itself, as I mentioned, is supported by Stockyard, which is mounted as /work, and that's mounted on all of the clients at TACC. And that's a 6.2 petabyte file system, also running Lustre. And fully dependent on LNet routing, so that's an extremely important technology that mostly, I think, only Lustre supports. And then we also have a fairly substantive tape archival system, which will become important when I start discussing our purge processes and various other operational requirements. Just a little slide showing the layout from top down of the machine room, and the IO racks are actually sitting, I don't know if I can point with the mouse, but they're the top right-hand row over there. It's probably all a little bit too small for you to see, but kind of the reason this slide is in here is because we always like to brag that Frontera is 8,008 servers in only 3 rows of our data center, whereas Stampede is 6,500 servers in 6 rows. So it's quite a bit more dense, but in actual fact we're cheating because all of the I/O is right up at the top in row 6 on the right-hand side over there. So Frontera actually does spill out a fair bit more than its claimed 3 rows. And if I actually just skip back one additional slide to the hardware summary, our GPU subsystem consists of 90 servers that all have 4 NVIDIA RTX 5000 cards. And that's an all immersion system. So when I started at TACC, we had 2 immersion cooling tanks from a vendor called GRC, Green Revolution Cooling. We're now up to 10 tanks today, and I predict probably that we will see more immersion cooling tanks going forward. And that's quite interesting, not specifically for our site because we have a raised floor data center and we're perfectly comfortable doing air cooling, but we are hearing a lot of people running data centers that are sort of looking for room neutral hardware. And the immersion cooling side of things doesn't interact particularly well with spinning disks. So I think that's possibly a theme that I will mention a few more times during this talk. And yes, I have heard people doing non-spinning disk storage systems in immersion cooling. Mostly anecdotal. I haven't seen it myself yet. But so yeah, we're up to 10 tanks, and 4 of those belong to Frontera, and that's 90 of our 4 GPU card servers in those tanks. Also not shown on this diagram. So Frontera is cheating again in terms of total space. Okay, so the thing that probably most people are interested in is the storage subsystem. We are in the category from the survey discussion this morning of our 2 flagship systems both run. The storage backends are kind of vendor provided, so we would have been in that little section of the bar graphs. As I mentioned, we're running 4 18K-X systems in failover pairs, which I will have another diagram of shortly, so you can kind of see how we map sort of mount points to specific controllers. If that's particular, it's not particularly interesting, but yeah, I think there's a fair amount of detail on the slide that probably is fairly system specific. What else is interesting? So one of the important items for us has been the fact that I think both the 2 flagship systems have both had their metadata servers moved to either the SFA200NV arrays, which is essentially moving our metadata to flash. I assume most people in the audience will have discovered that is a huge improvement to metadata performance. So some of our slightly older systems were still metadata on spinning. So that's kind of a big deal for us. The IME system is currently split up and attached to what we call Scratch 2. So that's the second to last bullet point over there. And that is, and then we're busy experimenting with the other 32 IME nodes that we have and just essentially building out kind of interesting flash-based file systems at the moment. And we've been doing that for about the last 6 or 8 months. So yeah, those numbers that you're seeing in terms of total capacity and total bandwidth at the moment, what is available to production is not the totals that are seen there. Also, that's not a Lustre file system. So we do have some additional storage options, and I said I'd mention Stockyard. So this is our site-wide file system, used to be referred to as globally shared file system. there's actually, oh yeah, there's the first mistake. Always fun when you find the first one of those. It is not a 10 petabyte file system, it's a 6.2 petabyte file system. The previous stockyard was actually 18 petabytes, so this is down quite a bit, but as a globally shared file system, this file system is one that we do quota. So on our Scratch file systems, we don't quota them at all, which necessitates that we do purge them. So that's kind of a big process. That's quite a big deal for us. We don't really like doing it, and we always inform users that if they clean up after themselves, we won't run a purge. So it's based on a percentage full threshold. But stockyard is quoted and it is not purged. And I've got some full statistics and a couple other things to mention on the next slide. And then additional storage options. So as mentioned, under the sort of heading of purging, users don't really like that process, and neither do we. But the Ranch archival system is a crucial component to that, and we expect people who are archiving their stuff to move it to Ranch, which is hosted in a second data center. So it is multi-homed, I suppose. And that is a subsystem that also belongs to Frontera. So this is the overall diagram that kind of outlines the majority of the file systems as they relate to all of our large-scale system clusters, all of the facilities that my group runs, also some of TACC's, the bottom right-hand block is TACC's non-HPC resources, so those tend to be things operated outside of the large-scale systems team. But Stockyard is, did I say 6.2 petabytes? I think I did. It's actually 6.8 petabytes. So you can see that in terms of capacity, we're still pretty comfortable, and something we experienced during the migration from the original Stockyard that was in production at TACC when I started to the replacement system. We went from 6 petabytes on that system down to about 1. So when you actually force users to migrate their data themselves, in our case, it was about a ratio of 1/6 was the data that people actually kind of spoke for and chose to migrate, and the remainder was abandoned data. Now, we kept the systems alive in parallel for quite a bit of time, and definitely over a year, and we got many requests over that period of time to recover specific items from the original file system, which we did every ticket bar the last one, which came in December last year. And by then we'd already started physical deconstruction of the old stockyard. So kind of the concept of how much data gets abandoned on these file systems, even the file systems that are quoted, and our quota by default is 1 terabyte. We'll almost certainly give away a 2 terabyte, more or less no questions asked. And then if people keep asking for more, then we'll start asking some questions about whether they should move to project space or, so in Stockyard's case, even that data, which we would consider to be of a non-scratch quality, there was a lot that was abandoned in that space. Stockyard is fully dependent on LNet routing, and LNet routing is, I personally think, a pretty amazing little piece of technology. We attach basically every InfiniBand fabric possible, I believe. Maybe that's an exaggeration. Apologies for that. So we attach OPA, HDR 100, HDR 200, FDR, and a couple of Ethernet hosts, which are a lot less interesting. If you look in the sort of second block down below the work file system, that's our client count as of Friday, I think I updated this. That's changing all the time because the clusters are large enough that there's always a couple of nodes out here or there. But I used to say it was in the region of 16,000 clients, and I think it's probably safer to say that we'd be close to 15,000 clients. But that's quite a few clients for any parallel file system. And in the case of the upgraded Stockyard file system, it's we've managed it pretty well. I think we're only, I'd say we're in a sub-tens of events that are user-caused issues on this file system. The previous one was mostly metadata, and I think a lot of the logic behind that was the move of metadata to flash-based. Stockyard is also the DDN 200 NV arrays, so that's 24 NVMe drives, I think, per chassis, and then a dual redundant controller. Then just taking a quick look over Frontera, you can see how Scratch and Home are both mapped from a single controller pair. Scratch 2 and Home 2 are also mapped from a second controller pair. And then Scratch 3 is a combination of another 2 controllers combined. So the approximately 56 petter is split up into two 10s and a 21 petter. And then they add in the IME subsystem as additional space into the sort of total space that Frontera has available. All of this is Lustre, and then this sort of, I suppose I switch to the Stampede2 system in a little bit, but just to mention, Stampede2 is built on the Zyrotex Cray Seagate cluster store. There've been a few names for this file system. Yeah, HPE, thank you. So yeah, it's a different vendor, but it's also Lustre. It's gone through a number of version cycles, but I'll get to that in a second. So that's the mapping of pretty much all of the storage for our 2 flagship systems at TACC. And Stockyard also applies to other systems. In the case of Maverick 2, it is the only file system on Maverick 2, so it doesn't have its own Scratch file system. Some of the details I've already mentioned from the diagram. Scratch 1, 2, and 3, you've got to see some of the capacities and the backend hardware that supports it. So Scratch 1 being general purpose, by default our users start out there. It is purged. We typically expect to purge roughly the total value of the file system per year on any given file system. That's kind of a rule of thumb. But in the case of Frontera, we did purge roughly 10 petabytes of data last year. Then Scratch 2 is kind of a second tier where problematic codes move, and it is also supported by the IME backend. So a lot of the transactions are being buffered to IME with reasonable success, and not amazing. And then Scratch 3 is the most capable. It's twice the controller count and twice the number of targets, as well as twice the capacity. That's never purged. We've got a number of groups. If I switch back to the prior slide, I can't remember the number. We're at 92% full on Scratch 3. So we've got multiple user groups. Never purged that file system. We do request individually to each user group as we start approaching the threshold numbers that we're at, to clean up after themselves. It is a constant battle. Mostly because of the size of Frontera, we also do the home file systems on Lustre, and that is, was indicated on the previous diagram, and is a slight departure from some of our smaller systems, which usually go with NFS. Sharing the controllers in that space is reasonably trivial once set up correctly, but it can have some unusual implications. We have seen some issues with sort of overlap between the 2 file systems, where alerts come from one that should theoretically come from the other. We also have 2 separate Home 1 and Home 2. Home 2 is very rarely used. We basically run syncs prior to maintenances between the 2 file systems, and that's just for the home file system allow us to restore under sort of emergency conditions a lot more quickly. We also maintain a tape backup of the home file systems nightly. I guess the biggest thing about these file systems is For both of our flagship clusters, they've been up for a reasonably long time. Frontera is roughly at half its lifespan, and Stampede2 is approaching end of life. So we have, run through a lot of acceptance testing. In the prior slides, you would have seen a number of the bandwidth numbers that came from acceptance testing. One thing that we probably should do, and we actually haven't done, is rerun some of the acceptance test benchmarks against the file systems that are extremely full. So once you get up to 92%, etc., there's at least anecdotal evidence, as far as I'm aware, of performance constraints within the file system. We have not done that specifically, but we're not deploying anything new here. We've been operating these for quite a while. In the case of Stampede, it's coming up on 7 years. And as I mentioned, it is approaching end of life towards the end of this year. Most of our problems are in the operational side of the file systems. So system monitoring is a substantial portion of that. So we collect a lot of performance data from nodes in a program called TACC stats, and so we can correlate, client performance with a lot of accuracy and a lot of fidelity. And then the main monitoring tools that we run are LLTOP and XLTOP, which I'll show a little demo for in a second. But it sounds an awful like what SDSC does, in that we have rolled a whole bunch of little back-end software programs that are extremely important to us, have been around for a long time. I believe the XLTOP author is a former TACC employee before my time. And then correlating that with IBTOP for the InfiniBand monitoring, because there are certainly occasions, especially in Stampede space, where the OPA fabric actually causes a file system event. We're extremely proactive in this monitoring. One of the things we really like about Lustre is if there's something going on with Lustre that's generally incorrect, it almost always shows in load on the servers. We find that's not true of all other file systems, but essentially if the server's load ramps up to anything specifically higher than near zero, and stays that way for any duration of time, then that's when admins start getting a little bit excited. So just a quick look over, apologies if some of this text started to get a little small. A quick look over an XLTOP example. So the server-side loads, again, as I mentioned in the previous slide, are the best indicator to us of concerns. And then we run a lightweight performance sweep, mostly metadata, every 10 minutes. And if that comes up slower than it should, then again, admins start getting interested. And then a couple of demonstrations of the XLTOP tool. So in the bottom right, you can kind of see a diagram of how it looks with the loads on the various metadata servers. And then it is slurm aware. So that's really quite nice. If you start looking at the job IDs, down the far side, I put a black box over some of the owners of the tasks, but you might even be able to see if they named their jobs according to, if they name their jobs with their own username in there or whatever. Anyway, I'm sure they won't mind. So some of the items for the tool, the -K flag being passed in there, that's currently looking at read, just basically sorting by read, by the read megabytes per second metric, followed by, so we can sort by reads, writes, and requests per second. These tools have had to be updated a couple times over the years as Lustre has moved things around in the /proc file system. So we just read that stuff out of /proc. Yeah, sorting. So then one of the negatives to this tool is there are cases where a user with a very large number of nodes, in the case of, say, Frontera, that can be 2,000 plus nodes by default in the queues. Those users could potentially run a very small read performance or a low number in read megabytes per second, and a user that propagates to the top of this list doesn't necessarily get caught trivially if their numbers are lower and they can be further down the list. Then sometimes we miss that. It's pretty rare, but then the other item for this tool is it actually takes quite a bit of time to average into the right metrics, so anywhere between 5 and 10 minutes to get the averages to actually indicate which job is potentially causing us the most problems. So yeah, this is something we've been running for an awfully long time now. We have looked into a couple of other tools, which are on the next slide. But just before I move on, one of the nice things about this tool is the final line there allows us to specify specific OSS servers, so we can just look at individual targets. And this is particularly interesting because one of our most common user-caused event is users that will put a single file onto a single target and then write it from thousands of nodes. That happens, it's probably our most common scenario. So catching that as soon as you look at the single OSS that's ramping up in load, you can almost always see exactly which job is hammering a single file in a single OSS. And then as soon as you ask them to use, MPIIO or just spread their load out over a larger stripe size, then the problem almost always goes away pretty much immediately. So then for monitoring, we have had an in-house tool developed. Unfortunately, the developer isn't with TACC anymore. He moved to Intel. And so we have deployed his tool on all of our file systems over about 2 years ago. We're sort of struggling a little bit with maintenance of this specific tool, and it's kind of the lesser used item, but essentially what this tool is, it's an XLTOP equivalent that logs to a database. So that's essentially exactly what you saw from SDSC. They also have a lot of internal glue software that's holding all this stuff together. And one of the things that we don't have with XLTOP is data over time. So going back on some of the prior events is something that's kind of challenging for us. It is deployed on all of our Lustre file systems. It doesn't do any of the other file systems, and probably never will at this point. We've looked into Prometheus and Thanos briefly. We are quite interested in file system indexing at the moment. That's not really active monitoring of the file system, but the reason it comes up here is because it is often the top item. If we are running an index on our own file systems, then we are often the cause of our own alerts. So file system indexing is something that once we're getting to the multi-tens of petabytes scale, kind of the logic goes that if you can find a couple of petabytes here or there of abandoned data, then getting that back, or at least contacting the researcher who's hogging that space and making them aware of how much they're taking, can save you real money. The trade-off is that, indexing is pretty expensive on particularly metadata load, and we don't have a specifically good solution to this at the moment, but we're exploring it quite a bit. So then usually the next step of in working with some of the monitoring for the file systems is to start governing I/O with a tool that is also developed by one of the TACC HPC group staff, which is essentially the client-side detection of I/O issues. It is user implemented, so we usually have to ask users to please enable the following module on their code. So we'll detect them as the most common candidates for overloading the metadata servers, and then we'll request that they activate a TACC module called OOPS, and usually that improves their metadata. Well, it degrades their metadata performance, but very deliberately from our perspective. So that also falls under the monitoring category. So there's a lot of software kicking around the back end that would be really nice to kind of get to be a level playing field, and it's been very interesting to hear about what other centers are doing, and it certainly seems like everybody's kind of got their own little tool that they're heavily dependent on, and if Lustre moves something around in the PROC-FS space, then we have to go and update all our tools, and I've done that on a few occasions now. But for the most part, well, let me not move to that just yet. for the most part, it does hold together, and I have some event items in the Stampede2 space, which I'll go over, and it's not a huge amount of file system events, and that's quite a nice improvement. So I have already mentioned that we do purge scratch file systems. I think this is the statistic of 10.6 petabytes were reclaimed on Scratch 1 on Frontera. So yeah, we expect to roughly purge the total space of the file system every year, which is quite, that's sort of how people expect Scratch to work. Well, many users actually don't. And then Scratch 2 and Scratch 3 are kind of pretty safe space, but we are constantly contacting users to please maintain their data within specific limits. We do keep quotas turned on the file systems, even when we don't enforce them, because it's a very convenient way to query their total file size at any moment in time. And we keep a record of exactly how much growth they have. But yeah, we're not enforcing the quotas at this stage. So if I switch very quickly to Stampede, this is the hardware overview, and I think you've seen a fair amount of this from the diagram that I showed earlier. Basically, the main thing to take out of this is that the vendor is not DDN, but it is still a Lustre file system, 18 petabyte usable. These are substantially more of the details for the specific file system. I am being somewhat pressed for time, I see, so I'm going to allow you to read that from the slide deck. I don't think anyone needs to see the rack layout. If you ever get to TACC, I'll happily give you a tour of all of this stuff, and I'll take longer than this talk at that. This is a very similar slide to Frontera, just trying to outline all of the storage available to the entire system. Obviously Stockyard is also mounted, and Ranch is also available. So, and then this was the slide I wanted to mention, and I think it is my second last, so I am nearly done. But just to go through the events, and I think this is fairly important. Our problems at the moment with the age of life of our two file systems are almost not Lustre at all. I looked back, and the last LBug that we hit was 2021 in Stampede land. So from our perspective, that's pretty good. We have gone through, all of the client-side upgrades over the years. A second item that we really appreciate about Lustre is that the client side and the server side don't have to align perfectly, and that all seems to hold out pretty well. So Stockyard is a much older Lustre than the clients on any of the main clusters. So there's multiple versions of software going all over the place in our machine room. And then, not a huge number of user-caused events, and we can roughly categorize them as too many metadata requests, writing to a single target on one OSS, and then a selection of sundry events, which some of those aren't even Lustre specific or file system specific. Another big one is that we have had 2 triple drive failures in Stampede land last year. Both were recoverable despite the outages that they cost us and no data loss, but you will see the bolded huge section over there. There's the sysadmin's worst nightmare moment where that underscore on the very first drive appears. That's not a good day. You're halfway through 2 rebuilds and you get a third. So final slide. We've very much experienced the concept that has been outlined for probably a decade, that with disk capacity increasing and RAID recovery events becoming longer and longer, we are more likely to trigger an additional failure. What are the reasons we think for this? Well, in our case, the declustered parity was still not enough, although it is a huge perk, and it also allowed us to fully recover with no data loss. We have done a proof of concept with GRAID. It doesn't particularly, GRAID is GPU accelerated RAID, and it doesn't integrate particularly well with our controller-based model, and we don't think it has better performance than our controller-based model. This could be an early adopter issue. We find certainly a lot of our hardware that we deploy is early adopter hardware or engineering samples. And so it could be that. And then the other one is a published article that implies that drives made after 2015 certainly seem to be missing their marks on later stage lifespans. We're running a bunch of proof of concepts on our IME hardware and other proof of concept hardware, which is all flash-based. And apologies for rushing towards the end of that, but are there any questions?
Hi, Glenn Lockwood from Microsoft. I'm surprised that failover failures was not the source of a huge number of your issues, your production issues. Could you comment on why that may be?
Failover between controllers?
Yeah, like that going south and both of them shooting each other in the head or something horrible like that happening.
We've had a fair number of failover events. Most of them fail over pretty cleanly. We did a whole bunch of BIOS updates in Stockyard, failed them all over. That was a deliberate failover, failed them all manually. Updated the BIOSes on all the servers, failed them back again, and did the other half. That is not high up on my list of things that fails.
Oh, good to know.
I'm pleased to say.
Thanks.
Actually, if I could just add a little more to that, one of the areas that we've experienced slightly more concern is on the VMs running in the 18K X's. So all the OSS servers are VMs running inside the same controller. Those have become wedged in ways where we've had to force them down and get them through recovery. So that's kind of close to a failover or lack of failover. And getting control over those VMs has been slightly different to what we're used to in physical hardware. So that's kind of close.
I had two things. First, I think real missed opportunity not naming your tape area pasture. Then you would say,
we have a pasture.
Oh, okay. All right. And then the other one was I noticed that you had you're running a lot of your systems pretty full. Do you observe anecdotally or have you measured any performance degradation by keeping them that full?
I did mention that earlier in the talk.
Apologies.
I'm well aware that we should probably run our acceptance tests again against file systems that are a lot fuller. Our understanding is that performance looks a lot worse at 90% full than it does at 25% full. We haven't measured how bad that actually is. So.
We have tools at Oak Ridge that does that in the acceptance periods. Deliberately fills up a file system and then measures the performance. So if you are interested, we can share those tools.
Very interested.
So commenting on your performance, I mean, you would expect to have performance degradation, right? Because you've got two factors working against you. First is overall fragmentation of the disk, which means the MB allocator is working much harder to allocate contiguous blocks, and secondarily, the physics of the spinning disk, right? It's just going to be slower as you start to allocate those inner tracks, and so I would be fascinated, once you guys finally decommission the system, if you have the chance, reformat it and then run your original benchmarks again to see what the hardware has actually done and aged over time.
That would also be extremely interesting.
Yeah, compared to that, because I suspect probably what you'll see is a significant fall off with overall benchmark performance just based on those two factors that I mentioned before.
Well, don't tell any of our users this, but our threshold is 88%. So once we hit that number, that's where we start considering purging.
So this is more praise for TACC, but as a developer, I've had a few. Oh, sorry. All right.
Got it.
As a developer, I've had a few performance problems reported from you guys over the years, and the TACC stats utilities and the data you guys provide from that is really good. You've got some good stuff there. So.
Well, I'm glad to hear that. And that is actually the same author as PFS Trace, so we're very sad to not have him anymore. And we expect similar things from PFS Trace, but unfortunately the push in that direction is a lot slower without him around. So.
I do want to comment about the accessing the proc stuff. That's the recommended way is the Lustre library has APIs to access those fields. And there's very good reasons because like you said, the data moves around, but the APIs protect that. And there's some work being done to make a more scalable approach versus something that's not using proc in the future. Some netlink stuff that I'm working on. So
I did indicate that we had some, our software broke when stuff moved around, so that's on us.
So yeah, but so that's the one thing is I could tell you the APIs to use and stuff afterwards, just to give you a note. And it's same with anybody else here. Please don't do that, please, because when you get, it's your fault. You can't be mad at me when I move the stuff.
It's too late, James. Everyone has already done it. So you should have said that 5 years ago.
Any other questions? Yeah, he has been saying that for the last 5 years. Yes, Stefan. Proving that we're not trainable. Yeah, some of us are not listening.
Hey, so I have a question about the triple failure, the triple drive failure. So usually in a RAID 6 configuration, when you lose 3 drives, you lose data. How were you able to not lose data?
So that is a pretty extensive ticket, and it's basically by leveraging the declustered RAID. I was also, quite honestly, I had my small, student mind blown that we could recover it all. It's a fairly substantial process that I did consider adding a lot of the details to that, but I can walk you through that ticket if you want. I make sure my guys collect as much data as possible about these procedures, but yeah, it is possible. I'm sure many of the people in this room will be like, yeah, we know it's possible, but I didn't know it was possible until I had to do it twice. But yeah, you essentially return. Well, it's a big enough procedure that I prefer to show you the background to it than try to.
Was it because the file system was not fully full? I mean, or
yeah.
Is it because decluster RAID is distributed, right?
There's enough parity.
There was enough
spread out around,
still
available that it can be rebuilt, and it does involve returning one of the drives that you had originally pulled out as the final failure drive. So it even goes and fetches stuff off the supposedly unavailable drive.
Thank you.
It's messy.
Any other questions?
With capacities in the tens of petabytes, do we think the rate of random bit flips is pretty negligible?
Yes. We run enough file system checks during maintenance windows to be reasonably confident that there's enough redundancy in the system. Yeah, I think it's negligible.
Okay, let's thank our speaker.